Good morning student. I am Mona Lisa. Welcome to my class. Today we will discuss about an interesting topic of your physics book relating to your daily life. Before going to the topic, can you tell me what happens when we switch on the fan? Yes, it will start rotating, but if we stop supplying current to it, then it will come back to its rest position. Now tell me what is the reason behind this and what is used in the fan that makes the fan to rotate when we supply current to it. Yes, very good. It is the electric motor. So our topic is electric motor. In this topic we will learn what is electric motor, what are the uses of electric motor, and what is the principle used in the electric motor, and also we can know how to improve the power or capacity of the electric motor. So let's start. What is electric motor? Electric motor is a device which changes the electric energy into the mechanical energy. The mechanical energy is also known as rotational kinetic energy. Why I called it rotational kinetic energy, you will understand it later. Okay. So in fan we use this electric motor to rotate the fan. It gives the rotational effect to the fan, not only in fan but also in so many devices like washing machine, driller machine, power pump, water pump, grinder, mixture, etc. You can make a list on that. Okay. So now we will discuss about what is the principle used in the electric motor. Let me recall some concept about it. You know that if we have to do some work, we need to apply some force. But how the electric current produce some force? According to Faraday, when an electric current carrying conductor is placed in the magnetic field, it will produce a magnetic force in a certain direction, and this direction can be calculated by Fleming left hand rule. Okay, so the magnetic force will be maximum when the electric current is perpendicular to the magnetic field, and the magnetic force will be 0 when it is parallel to the magnetic field. Okay, so to understand this concept we have to create a magnetic field by placing the north pole and the south pole oppositely facing towards each other. Then the magnetic field will produce from the north pole to the south pole. We have to place a rectangular loop in the magnetic field to experience the rotation. Why we take a rectangular loop? Because we have to produce a torque. For that we need two types of opposite force. Okay, you can see in the figure the current supplied to the loop through the point P, and it will be exit through the point Q. Then the AB arm will experience a downward force while the CD arm will experience a upward force, and the BC and AD will experience no force. Why? Because these are the current in BC and AD is parallel to the magnetic field, so there will be no magnetic force. In AB will experience a downward force and CD will experience a upward force according to the Fleming left hand rules. What is Fleming left hand rules? According to the Fleming, when the middle finger, forefinger and thumb are arranged in mutual perpendicular direction, then the middle finger will give the direction of current and the forefinger will give the direction of magnetic field and the thumb will represent the direction of magnetic force. Then for AD we see for AD the forefinger will show the direction of magnetic field and the middle finger will show the direction of electric current. Then the resultant magnetic force will be shown in the downward direction like this. Again for CD the arrangement will be like this. The forefinger will show the direction of magnetic field and the middle finger will show the direction of flow of current and the thumb will represent the direction of magnetic force in upward direction like this. So we can see in the ABCD loop the AB will experience a downward force and CD will experience the upward force. So how it looks like? You can see that it is the AB arm and it is the CD arm. If AB will experience a downward force, then it will be rotate in anti-clockwise direction and CD will experience a upward force, then it will be like this. When the half rotation is complete, then the AB is at the place of CD and the CD will be at the place of AB, then it will reverse back in the clockwise direction like this. As AB will always experience a downward force and CD is always experience a upward force. It will be like this. Okay, you can try it by your own. Okay, so it does not give the complete rotation. For that we have to change the direction of magnetic force, which is possible if we either change the direction of magnetic field or the direction of flow of current. But practically, simultaneously changing the direction of magnetic field is not an easy task. So we have to change the direction of flow of current by changing the polarity, which is possible by using a commutator, which is consist of split rings and brushes. The brush will give the flexible rotation to the commutator or the split ring. So in this way the whole motor will rotate and it will be experience a rotational motion. In this way we can change the direction of magnetic force and provide the electric motor to get the complete rotation. This is all about the working principle of electric motor. Now the next will be how to improve the capacity of an electric motor. We know that F, what is the formula for force? It is the B into I into N. What is B here? B is the magnetic field intensity, or we can say that magnetic field also. What is I? Current. What is L? Length of the conductor. As we have to increase the capacity of an electric motor, which is depends upon the force experienced by the loop. Here you can see that force is directly proportional to B. That means if we increase the magnetic field, it will increase the magnetic force. How can we increase the magnetic field? We can increase the magnetic field by using an electromagnet instead of an paramagnetic substance. And the second condition will be force is directly proportional to I. We can increase the force by increasing the current flowing through the loop, or by providing more current, the force will be more. And the last will be force is directly proportional to L, that is the length of the conductor. If we increase the length of the conductor or by increasing the coil around it, we can increase the capacity of the electric motor. Okay. This is all about the electric motor. So I hope this concept is clear to you, and we can solve the problem by using this concept. If the question will be, what will be the total torque produced in this arrangement when the magnetic field is 2 Tesla and the current is 3 ampere and the length of the loop is 4 meter and the breadth is 2 meter. What will be the total torque produced in this arrangement? You know the formula for torque. What is it? The cross product of force and displacement. Here it is the displacement, angular axis of rotation. What is F cross ds? The formula for F cross ds, F ds cos theta. Here theta is the angle between the axis of rotation and the force. These are the parallel to each other, that's why theta will be 0 degree, that implies cos theta will be 1. You know what is the value of cos 0, that it will be 1. So what will be the formula for the tau? That is F dot ds. It is the formula for the torque. Okay. So to calculate the torque, we have to calculate first what is the force produced in this arrangement. What is the formula for force? We have seen F is equal to B I L. B is the magnetic field, I is the current, and L is the length of the wire. Here what is the value of B? That is 2 into 3, and what is the length? That is the 4. So it will be 24 Newton. Here the force will be 24 Newton, and here also the force will be 24 Newton, as two forces are produced in this arrangement for AB. The torque will be produced tau 1. What will be the value? Force into displacement. For here the force is tau is an vector quantity. So what is the value of force? That will be 24, and the displacement. What is displacement here? It is the distance between the axis of rotation and the force, which will be the half of the breadth. Here the breadth is 2 meter. Then what will be the distance between the displacement, the axis of rotation and the force? It will be 1 meter. Okay. So the total tau produced in AB will be 24 Newton into meter. Here it is the unit of force and the meter is the unit of displacement. Like this, tau 2 will be also 24 Newton into meter. So the total torque produced in this arrangement will be tau is equal to tau 1 plus tau 2. That will be 24 plus 24 is equal to 48 Newton into meter. It is the tau, total tau produced for this arrangement. Okay, I hope you will be understand this. So I hope the concept of electric motor will be clear to you. If you have any doubt, you can ask me in the comment section. Thank you.